Okay, here are two examples that involve perimeter of a basic shape. So the first one's going to involve a rectangle, the second one's going to involve a triangle. So I did write the formula for a perimeter of a rectangle up here. This would be the one that I would memorize. I wouldn't worry about the other ones that I showed you in the notes as much, although they sometimes get stuck in your head anyway. So here's the problem. It's a word problem. How much fencing is needed to enclose a rectangular garden that is 25 feet long and 12 feet wide? So let's first of all draw a picture of this garden. So it's a rectangle, so we're going to draw a rectangle. All right, so there's my rectangle. It is 25 feet long, so the length is 25 feet. I'm going to actually write that on both sides for length. It's 12 feet wide. Again, I'll write that on both sides. I mean, technically, all we need to do is add up those four numbers. Well, this formula does it for us. So I'm just going to simply say the perimeter equals 2 times the base. The base is 25, plus the height. The height is 12. So technically what you're doing is you're adding up one base, one height, and then you're doubling the answer. So we're going to get 2 times 25 plus 12 is 37. And just to double check that, we will use our calculator. 25 plus 12 is indeed 37, and then we multiply that by 2, and we get 74. Now, 74 is our answer, but it's not complete because we haven't put a unit in, and that's really, really important when you're dealing with perimeter and area. You look for a unit. This one has a unit. It's in feet. So this is just a distance, so we're going to call that 74 feet. The second problem is a triangle. So as we look at the triangle, we see that it's already drawn on a number line. And so what you're going to look at is each of the points, and we want to actually find the distances. So the first thing I'm going to do is, I don't have a formula for a triangle, so I'm just going to simply find out the distance of this segment, the distance of this segment, and the distance of this segment, and I'm going to add those three numbers together. So if I first of all look here, since it's on a number line or a coordinate plane, it's easy to find the distance. I'm just going to simply count it over. So it looks like I'm going to go 1, 2, 3, 4, 5, 6. This distance is 6 units long. There is no unit this time. It's just called units. Up and down, we're going to start, I don't care at the top or the bottom. We'll start here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8 units long. So that distance is 8 units long. This is slanted, so I can't just count it because these distances aren't uniform. So what we're going to need to do is we're going to either need to use the distance formula, which I don't really like, but I like to use the Pythagorean theorem. We all know the Pythagorean theorem is a squared plus b squared equals c squared. And c, the hypotenuse, that would be this distance. So that's going to represent our c, and these will represent our a and our b. It doesn't matter which one. So I'm simply going to plug 6 in for a, 8 in for b. I get 6 squared plus 8 squared equals c squared. Well, 6 squared is 36. 8 squared is 64. We'll add those together. 36 plus 64, I believe, is 100. 36 plus 64 is indeed 100. And so c squared equals 100. The square root of 100 would be c. That's going to be 10. So this distance is 10. And that makes sense because the hypotenuse is always the longest side. And it's a hypotenuse because it's a right triangle. It went straight across and then straight up. So I know that this is a right angle. So without that, we may not have a hypotenuse. We may not be able to use the Pythagorean theorem. But since this is a right triangle, we're okay with that. So there's the other distance. I just now need to add all these distances together. 6 plus 8 plus 10. So 6 plus 8 is 14. 14 plus 10 makes our final answer 24. But remember, we have to put a unit in here. When there is no unit, we should use the word unit or just a U to represent unit. And there's your two examples for your perimeter.